Okay, so we have a small video from James MacFarlane of Cantabria Labs, who will be giving a quick update on visible light.
We've been working with some key opinion leaders, preparing some webinars, preparing some symposium, and we've been doing a little bit of more work on visible light. And so I thought I'd just show you, this is more like a training than a scientific publication, just to show you the most recent developments in terms of visible light in the scientific and dermatology community. So it's been clearly established now that visible light causes damage to skin. Cantabria Labs was the first company to market sunscreens protecting against visible light. It was the first company to help doctors understand that visible light can in fact cause skin damage. We know that now more and more competition are starting to use our claims. We're not always sure based on what scientific evidence. We continue to have strong scientific evidence, and as you know, we are moving ahead. We've talked about blue light from digital devices, and so we are staying ahead of the competition. But visible light damage induces biological effects on the skin, including erythema, oxidative stress, hyperpigmentation, and DNA damage. Okay. This has been very well established. The visible light range from 400 to 770 nanometers, and we will be focusing particularly on the 400 to 500 nanometer range. Increasing importance is also being placed on the UVA radiation. There are two types of UVA radiation, UVA2 and UVA1, and there's more and more evidence regarding the specific damaging effect of the UVA1, and we'll look at that in a moment. So we know that skin is damaged by visible light. A study in 2014 demonstrated that within the visible light spectrum, as I said, from 400 to 770, the higher energy blue-violet light causes considerably greater pigmentation than red light. So this is the visible light range we have. The blue and violet light causes greater pigmentation than the red light. This was demonstrated in a study where they irradiated skin with 415 nanometers. Okay, so you see here the violet blue light, and with 630, so getting on towards the red light. Okay, the lower the values, the darker the color that was induced by the radiation. You see that 415 had a significant impact on darkening the skin, whereas 630 did not. So when we focus on the high energy visible light, when we focus on the blue light, it's because this is the part of visible light that causes skin darkening. Then the study went on just to show the effects on the skin of a dosage of approximately 2 hours and 45 minutes of visible light. Okay, so again, it's not a huge quantity of visible light. In unprotected skin, you can see the effect that it has on skin in terms of the development of immediate and delayed pigmentation. So again, in phototype 3, in phototype 4, we can see the effect it has on increasing pigmentation. So visible light damage, especially the blue and violet light. And this damage is considerably greater than pigmentation by UVB, okay? This is very important. UVB is usually attributed as being the main cause of skin pigmentation, but here what they saw is that blue light, or the blue light range, can actually cause more hyperpigmentation than the UVB. Here we see UVB and blue light, UVB and blue light. So the pigmentation caused is primarily by the visible light and not the UVB. Another interesting group of studies showed that the damage from visible light and the pigmentary effect of visible light varies according to skin type. That in darker skinned subjects, so 3, 4, and upwards, especially 4 and upwards, it causes hyperpigmentation, whereas in light skinned subjects, phototypes 1, 2, 3, it causes erythema. Okay, and this is important because recently, talking about visible light, most of the focus has been on the darker skin types with the pigmentary effect, but also it has been demonstrated that it has an effect on light skin. The effect is erythema. Here you can see the results of the study, where we see that the radiation with visible light increases erythema in light-skinned subjects. We know that erythema is inflammation. We know that inflammation causes damage to skin through skin aging, hyperpigmentation, stimulation, damage to DNA. So the erythema produced by visible light in light skin types is also very important. Okay. Another recent finding, very interesting, is that the UVA1, okay, which we talked about earlier, which is the 340 to 400, so the part closest to visible light, it can combine with the visible light to provide even greater pigmentation. Here we have different phototypes with different exposures, exposure to visible light, and then exposure to visible light and UVA1. And if you see here, the pigment caused by the combination of visible light and UVA1 is much greater. So what does this mean? Fundamental to protect against visible light, but it's very important to ensure good protection against UVA as one, because it's the combination of the two which can provide very significant hyperpigmentation. Okay. We know that we have data showing that FermBlock and HelioCare can protect against visible light. Okay, so and the exponential damage of visible light and UVA1. We have FermBlock, where we have demonstrated visible and blue light protection. We have in some of our formulations iron oxide, which provides visible light protection, and advanced UVA protection through our filter Tinosorb A2B. Okay, so we're able to specifically focus on the concern of visible light and on the concern of visible light and UVA1, particularly in our specific target formulations, pigment solution and age active. So just very quickly, we have FermBlock in vitro protection against visible light, published in 2018. We have FermBlock in vitro against blue light, which was published just this year. You remember the first active with demonstrated activity against blue light from digital devices, increasing cell survival, reducing oxidative stress, protecting cell morphology, and reducing pigmentation through two different mechanisms, reducing the oxidation of the melanin already present in the skin, and reducing the expression of opsin-3, which is the pathway for increasing pigmentation in skin due to visible light. Then we have again the Mohammed study, where we have again shown in vivo that FermBlock is able to reduce the pigmentation, inflammation, and MMPs induced by visible light. So evidences for FermBlock. Again, as I said, in our target formulations, pigment solution and age active, we also have zinc oxide, which helps to enhance and strengthen the visible light protection offered by FermBlock. And then the advanced UVA filters. Okay, so in the pigment solution and age active, the filter Tinosorb A2B, which is from BASF, which you know is the leading international company in the development of advanced and novel sunscreen. This Tinosorb provides very good protection against UVB, UVA, and you see it also provides protection into the visible light range. Okay, so with Tinosorb A2B and UVA plus, we're able to provide the protection against the AV1, which can combine with the visible light. So complete protection. We add on top of that our Fern block. So conclusion, HelioCare is the only sun protection brand offering filtering and biological protection against damage from visible and blue light through Fern block and then through the zinc oxide, the iron oxide and the advanced UVA filters. Again, so another guarantee for our doctors, pharmacists, and patients.
All right, and there you have it, a refresher on the visible light spectrum. Excuse the lawnmower in the background. We are in Auckland and still in lockdown, so I'm keeping busy by helping to train your staff and provide updates on regular information. So as always, if you need more information, do check out our YouTube channel or our Solafern website, or do get in touch with us about stocking HelioCare, or if you have any specific HelioCare questions.